I hope my screen is visible to everyone. Yeah, thanks for the reactions. Okay, let me start with the basic questions which we always do. So, what are the 5 V's of big data? This is not good actually. Anyone should say something, right? Be it one, even if you remember one, you should say that, right? Muting
Velocity,
yourself.
veracity, variety, volume.
Correct. What do we mean by veracity?
The extent to which the data can be trusted.
Yeah, good. Thank you. See, only one person is answering the things. I don't think this is the correct thing. Every day you come to the class, okay, I think you are having mid exams, right? That's fine, I can understand. Just say something, whatever you remember. Even if you don't revise, sometimes you will remember a bit, right? At least say something, okay? Try to say something, everyone. Okay.
See, if you hear attentively, you can tell. Okay, this is not big topic also. I know all the topics just by hearing this class. Next question she will ask what is variety, all these questions, right? What is RDD and what is the DF? Same thing every day, same questions. Just by hearing the answers, you can answer itself. No need to separate preparation. Okay, just pay attention this 1.5 hour or 2 hours. Okay, that will help you. Yeah, Karen, madam.
Thank you, sir. Yeah, so we have discussed what are the 5 V's of big data: volume, variety, veracity, and 1 minute. Volume, huge amount of data. Variety, different types of data from different sources. Velocity is about the speed at which data has been generated. Value, extract the meaningful data. Veracity, the degree to which the data can be trusted. So these are the 5 V's of big data with definitions today I have told you. So from tomorrow at least, I'm expecting everyone to open up. Okay.
Or take the screenshot.
Yeah, exactly. If
Okay,
you
take the
every day I'll
screenshot.
be asking you the questions, at least remember those because these are the very basic questions which may come in your interview panel because at fresher level they will ask the very basic questions only. They'll not go deep into the subject. Okay, so just remember the things at the basic, very basic level. Okay, what are the 5 V's of big data? What is Hadoop? What is Spark? How Spark has come? What is the difference between Spark and Hadoop? Spark and Hadoop. So see, when I ask you when someone asks you what is the difference between Hadoop and Spark, you need to tell them that we are just replacing the Hadoop MapReduce, means that is compute engine, with the Spark, but rest all remains same. This will give them the opinion that you already know the basic things at a strong level. Okay, clear everyone?
See, these all will come in your technical interview. Okay, everything is important. Okay, so they are going to ask all these things.
Definitely, it will help to you. As I shared you the PPT already, whenever you get time, just read it. I don't say read it every day, just go through this whenever you get time. Okay. So, in order to start today's session, I want only two things. that is difference between Hadoop and Spark. This is the major one. So take a screenshot of this or read it. I'm telling you the very, very, very important things. Okay. Hadoop architecture and Spark architecture, Hadoop and Spark. See, they will not ask you to draw it, but they will ask you inside the Spark architecture, what do we mean by DAG? How the Spark, inside the Spark, how the job execution will happen. So this is all the things they will throw you during the technical interview. What are the differences between Spark and PySpark? You can tell them, okay? Differences between PySpark and Spark. And also this particular one, RDD operations. We have three: transformations, actions, and persistence. So what is the difference between these two? Mainly when it comes, and persistence is the separate thing. It is all about the caching. So don't worry on that one. When someone asks you, tell them three. But in depth, if they want to ask you, they will ask you about the transformations and actions. They will say, like, list a few of the transformations or few of the actions which you know, something like that they will ask you. So the basic thing is, until action has been initiated, the transformation will never execute anything. So this should be the thing which should register in your minds, that transformations are lazy, so they will not execute anything until the action has come. So every time when you write a transformation function, like map some RDD dot map of something you have written like that, but it will not execute. You need to write dot collect off, then only it will give you answer. Collect is from actions. So that is the thing which you need to remember. And every time, see, whatever you write in transformations, it will not give you the answer. You need to take the collect one. And one more thing, collect is for only small data sets. I have showed you all the things with the very basic examples, taking only 10 records max. Okay, but think from the big data level, what it will do when you write collect. If it is big data, it is hard to accumulate everything in the memory which was allocated to us. Okay, so it is not possible when you are dealing with big data, the collect function. Okay, remember this thing also. And they will also ask you on the reduce function and the fold one. Differences between reduce and fold, definitely, because both will be the same thing, but in fold there will be one value which is uh, dealing with gloom also. And I already told you in transformations, we have gloom also. What is gloom? What do the gloom do? The gloom will show you the partitioned data. Means when you write collect, it will give you all the things. But in which partition, what data is there, gloom will display it. Okay, so gloom is a transformation function and it will show us that particular thing, in which partition what data is there. So gloom is also major thing in from interview perspective. And why in transformations we have narrow and wide? Because of shuffling. Okay, shuffling, if we have in wide transformations, shuffling will be more, and in narrow it is like this. Shuffling is not required much. In wide it is largely required. So this is how, when you read something, na, learn from differences. Why? For joining the data, it requires shuffling the data. But when filtering the data, it is not required. For mapping the data, also it is not required. For union also, it is not required, because just you are just combining the things. Okay, repartition and coalesce. The difference between repartition and coalesce, I have given it here. So this is the difference between repartition and coalesce. So both are very expensive, but compared to repartition, coalesce is bit less expensive. Okay, because what it will do for any given RDD, this repartition will adjust the data, increasing or decreasing the partitions. But coalesce is not like increasing it. It will always try to reduce the partitions without shuffling. So that is the major difference between repartition and coalesce. Okay, so today we will be discussing about the joins. Yesterday we discussed about window functions and aggregate functions, right? So today we'll be discussing about the joins. So give me a moment, I'll open my notebook. Anyone having any doubts? Yes, 7:49. Do you have any doubt? Okay, I'll take this as no. See, yesterday, what we have discussed majorly is it is all about the data frames with UDF, how we can create the UDF and how we can integrate the UDF inside our data frames. That is what we have discussed. When you are dealing with UDF, you need to import from functions this particular UDF one so that whatever UDF, this is the user defined function. UDF means user defined function. So I have taken an example of this one. So cube, this is the UDF one. But before, I cannot take this directly into a data frame and ask it, right? So what I have done here inside a data frame, I have called the UDF function and I have given what is the name of the UDF which I have given, and this is the return type. So the return type of this is integer type. If I didn't specify anything, it will take the string type. So this is how it is in UDF. And when you are dealing with large data, the data frame dot select of this particular thing was again assigned to one variable, which in turn it will create a data frame. So df underscore udf of what upon what column you want this particular uh, UDF to be executed. I have given the rank one and I just given alias of this cube of rank. Okay. And I have taken all columns also to show you. So this is how it has given me the UDF, how we can use the UDF inside the data frames. Okay, this is one example we discussed, and other example is this one we have discussed yesterday. And most importantly, we discussed about window functions. So definitely, guys, window functions will also play the major role. See, even if it is experienced person or a fresher person, there will be definitely a one question on this window functions. I have seen. Okay, so they will generally ask the differences between row number, rank, and dense rank. Okay. So yesterday we discussed, right? To see when you are working with UDF, you need to import UDF from PySpark.sql.functions. But when you are working with window functions, you need to import PySpark.sql.window. From this one, you need to import window. So see, when you are writing like this, it is small letter of W, and when you are importing it, it is capital W. Even a small mistake of this also will give you an error. That's why I'm particularly saying you this one. Okay. So window. So be it a row number, rank, dense rank, lead, lag, whatever we have discussed, what we are doing exactly means we are first partitioning the data and we are ordering the data. So partition on what we need to give. See, here I have taken state. You can, there is no need of taking only one particular column. You can partition it based on state, city, or state and city also. Multiple columns can be incorporated within the partition by and order by. Okay, what it will do means first it will partition by state, and inside the state we have number of cities. So upon cities also, it will again partition. So that is how it will work. When you give in this one also, when you give like order by of this population I have taken, population, and also you have rank like this, or any other column you want, you can take it. First, it will order by this one, means it will take, I have not taken ascending or descending. So what it will generally take, it will take ascending order only. So the least one of population will be ordered in the first one. And comma, if you have given any other particular column, then at that moment also, what it will do means, first it will partition by this, and then later, sorry, order by this, and later it will be partitioned by that also. Means with respect to the partition, let's say state Alabama, here you have seen few examples. Okay, so Alabama order partition by this. Okay, we have taken, and order by population estimate. So this is the list, that's why this has come up first. When you are giving order by city also, if you have taken, let's say, then what it will do means, it will do along with this population and also the city. Means first it will check the list of this population, and also then it will check, see here the different numbers are there. So here you couldn't see it, but when you have, let's say, Mobile and Montgomery, both of them are having same numbers. Then if you have given order by population and city, then first it will take, according to this one, to same number, right? So then it will go to city and Mobile and Montegory, both in, out of both, which will come first? Obviously mobile, because B is the least one with respect to N, right? Means its ASCII value is less than this. So that is how it works generally. Okay. So not only one column, you can take any columns when you are partitioning and ordering. This is the very useful thing in real time when you work with big data sets. All the window functions like row number, rank, and dense rank are mostly used. Okay. So window dot partition by state and order by this particular thing we have taken. And next one, what we have taken, data frame dot with column of, we are creating a new column, row number, right? So row number, and how we are defining this row number, it is with respect to row number function. Row number of dot, see, when you write it in SQL also, the syntaxes will be almost the same one. It will not change much. Okay, I will show you that also when we are working with Spark SQL. I'll show you that also in while we are dealing with this one. Okay, don't worry on that one. So for now, row number dot over what, over this particular one. So I have taken it into one variable and utilizing the same thing here. Partition by state and order by population. So this row number over this and this. So it will give you the answer accordingly. So we also checked the rank one also. So to show you the difference between rank and row number and dense rank, we have taken a new one, right? So let me copy it and paste it, because today also we may use the same thing. Okay. So I have created a sample data, and now which is having the employee name, department, and salary. See, if you see here, department, sales and sales, finance, marketing. So finance, in finance, two persons, Leo and Jerry, is having the same salary. So at this time, what do the rank do? We shall see now. See, in finance, 1 and 1, both are taken as 1, and 2 has been skipped because 1 has been repeated once. And we have got 3 in finance, and marketing 1, 2, sales also 1, 2. So this is how the rank has been executed. When you say it for row number, see, in finance, 1, 5,000, 5,000, 6,700. But see here, it will be taken as 1, 2, 3 only. So that is the difference between rank and row number. In row number, it will assign values 1, 2, 3 directly. It will not take as rank. Like if both are same, it will not take like this. And when you use the dense rank, what will be the answer? Yesterday, I asked you to check the dense rank upon means like an assignment check from your end. I told you, no? Has everyone done that one? I could see only one reaction. Okay. Okay, I can understand. You have mid exams. That's fine. But see, when you execute it for the dense rank, what it will give you here in the rank 1, 1, 3 has come right here. At that moment, it will give you 1, 1, 2 only in the dense rank. So that is the difference between rank, dense rank, and row number. So even when you are in sleep, if someone asks you the differences, you need to able to answer the question because it is very important from interview perspective. Okay. Lag. Lag will give you the preceding value of the same column. Here I have taken lag on salary. Okay, so what it has done for 5,000, the preceding value is not there. That's why it has taken null. But for this 5,000, we have 5,000 above, right? That's why we got 5,000. For 6,700 also, the preceding value is 5,000. So it is like this. So this is for one partition, and for marketing again it will start new iteration. Okay, this is how it will work for lag. When you deal with lead also will be the same as lag, but the difference is in lag you have the preceding value. Here you will be having the successor value. Like see, for 5,000, it is 5,000 only here. For 5,000, it is 5,000 only. Again, for this 5,000, it is 7,000, 6,700. So it has been displayed here. So the next value will be here. And for this one, the previous value will be there. Okay. So this is how the lag and lead differs. Okay. So today we will be discussing on the yesterday we discussed about a few aggregate functions also we can use in window. So window functions. So how we can use that we shall check now. Okay. Let me input few things before going. Okay. Input PySpark. Input SQL dot. I'll write star for my for today's class because we will be needing to import many of them. So that's why I have taken this one. From this I'm inputting all. But see, when you are working with real-time data, it is not good coding practice to import star. You need to take what are all it is required. Like if you are working with column or you will be working with max, min, average, sum. So today we are going to discuss on these, right? So I have given this one. The number also will be discussing. Then is rank. From PySpark, SQL, window, input window. Okay. So let's start. Let's start with this dense rank, okay? Dense rank. Let me take as D rank. So what we need to do? Window dot partition by. Let me execute this. Okay, two commas are there here. Partition by department. Order by of salary. So this is the window we have created, and now we are utilizing df underscore dense rank is equals to this particular df is only just df dot select with the new column with column of. So we are taking column as dense rank today. Dense rank and dense rank of it is over which one? df dot underscore d rank, correct? So let me execute this, but I haven't written show off value. Let me show you. See here, 5,000, 5,000, 1 it has taken, but for 6,700 it has taken 2, but in rank it has taken 3. So this is how it differs. Okay, now let's move to the next one, which is aggregate. Okay. So for aggregate functions, now what I'll be doing means I'll be incorporating all the values here only. Let me create a window. See, the aggregate functions. What are the aggregate functions we have? We have taken min, max, average, min, max, average, sum. So these are all aggregate functions. So think from this perspective, like when you are summing the things inside the partition, do we really need order? It should be in a particular order. Do we think it is necessary to order the things for this particular aggregate functions? See, maximum value will give you the maximum value. Max will give you the maximum value. Min will give you the minimum value, average and sum. So for all of these, ordering the things is not at all required, right? So, but for rank, dense rank, row number, ordering is must and should. But here, for this one, it is not required. So when you are dealing with this one, what you can do is df underscore aggregate. So what we can do, window dot partition. Only partition by department should be good enough. Okay. Ordering is not required now. So df underscore is equals to df dot with column of. Let me give it as sum only because I'm going to do sum. So sum of what? So today I'm going to use this particular sum on with respect to what? The column should be the salary. So see, above it is giving the suggestions. It should be the column or the name. So let's see what it will do. If it is not working, we need to write as column of salary. Okay. Let me see. So salary dot over the window is df underscore aggregate. Let me show you that one. So the sum of all this is the value, and for some of these two, this is the value. So since we have not taken like sum of each partition, we got it, and we are getting the same value everywhere. So this is how it is. Let me show you one more thing. Apart from this one, if I want if I have taken the backslash like this one, it means that we still have a continuation one. Means the query has not ended there. What I will do now means I will be writing sum, average, all, everything now here. Df dot with column of. Let's take average now. Average of salary. And the window will be aggregate. Okay. So now again, after average, I'll create one more, which is df dot maximum value and minimum value also. Max. Max of salary over df underscore. So every time I say slash, then what it will do means it was taking the continuation. Okay. So this time it will be min of salary. Min of salary. Okay. So this is how we will be doing this one. Now let me select upon all these. Okay. Dot select of. Now I am selecting what department. Department sum average value and max minimum value. Okay. So now I will give the show. Now let's see what will be the value here. What it is saying. Okay. So here every time when we do the DF is not required when you are adding a new column. Just say it with a dot. This particular slash it is showing as error and everything is correct with column of minimum of salary dot or of df underscore aggregate. Okay. So what it is saying, unexpected character after the line. Okay, so even the space also it is not going to take it. Now what happened to this? Max is not defined. Okay. Max is defined, right? Okay. Max and min. See, for department finance, these all are the things. But see, I want only one, right? What I will do this thing of the flow. What it has given us, the distance value. So this is how we can write it. Please take a note of this one. Give me a moment. I hope everyone has taken a note of this one. So now we will be going to the next topic, that is joins. Okay. So see, how many types of joins we have, we shall see now, and then we'll be discussing it practically later. Okay. So in joins, same like we have in SQL, we have inner join, left join, right join, full join. See, left outer is seen as left join, right outer is same as right join. Okay. And full outer or full, both are same. And here, apart from these joins, we also have left semi join and left anti join. Okay. And we inner join, what it will take means it will take the matching keys only in both the data frames. And when it comes to the left join, it will take the left part completely and matching records of right. And when it comes to right join, same as SQL, it is the same it is doing. Taking the rows from right one and matching records from the left. in full outer join, what it will do means it will return all the rows from both the data frames, including matching and non-matching rows for full outer join. Okay. And the new joins which you will be learning here will be left semi-join and left anti-join. So in left semi-join, what it will do, it will return all the rows from the left data frame where there is a match in right data frame. Means whatever the matching records are there in the left, those only it will be reflecting, but not the other values of left. Okay. Uh, just understand this. We will be discussing with practical also. And in this left anti-join, what it will do, this is the reverse of this semi-join. Okay. So what it will do means, return all the rows from the left where there is no match in right. Opposite of semi is anti. Okay. Let me go to the practical one now. So we will be discussing inner. So let me first explain you the syntax of this particular join. Okay. So before going to that one, we have only one table, right? So let me create a table first. Employee table and department table. Okay. So emp equals to array of tuples. Let me give the employee name and uh, manager ID. Manager ID and what else we can take here? Department ID. Department ID also we can take like this, department ID and the gender, male or female. Now we can go to the salary. Okay. So let me copy paste all this for all the values and let me change it. You can also create one on your own, okay? No need to see my screen. By the time I create, you can do it yourself. Yeah, I've created a table and now I'll be creating the columns. Columns will be employee ID. Everything I'm taking in small only. EMP name. And this will be the manager. Manager ID. And department. Department ID and gender. Salary. Okay. So how do we create a data frame? EMPDF is equals to create spark dot create data frame of data is equal to employee and schema is equals to EMP columns. Okay. Df dot show. Okay. So this is how we created. See, manager ID here we have taken a note. So employee ID, employee name, manager ID, department ID, gender, salary. Let's create a department. Okay. Department is equal to this one. So department is finance. Finance department ID. Let's say 10. Marketing. Marketing will be 20. What else we have? Sales. It's 20. But 50. Okay, yeah. 30. IT department. Okay. Let's we have only 140. Department name. Department ID. Okay. Let me create DEPT DS equals to star dot create data frame of create data frame of data equals to department and schema is equal to sorry DEPT columns. Okay. DEPT here show. Let me show you that one. Okay. Okay. So department name and ID we have. So let me go with we have created two tables, one for employee and one for department. And now we are going to see all the joins. Firstly, inner join. See, understand the syntax. The syntax will be the same for each and every join, okay? So now df underscore inner join, how we are going to do this. Let's see. So the join. Now, how we usually join the things, left table and right table. So simply, now whatever you are giving here, EMP, we have taken as employee DF, EMP DF, right? EMP DF. Let me take it as small only. Okay. So EMP DF dot joining of the other one is DEPT DF. So employee DF dot join of department join. Now on what, see, joining left table join right table. Now on what condition it should join, means what are the matching records it is asking. So what is the matching one in EMPDF dot what we have department ID. DBT underscore ID is equal to department DF dot, here also it is DBT ID only, na? We can paste it here. Here also it is DBT ID. Okay, I'm joining based on the department IDs here. And which join I want? I want inner join. Sure. Okay, so let me execute this one. See, if for equal to, it should be double. It is saying that. So I have joined it as inner join. Let me explain the syntax once again to you. Left table dot join of right table, and here the join condition should be there, and here it should be inner join, left join, right join, or whatever the join you want, you can take it here. Okay, so see, this is left dot join dot right of condition comma join. Which condition? How to join this one? Inner, left, or right? So whenever you hover on this one, see, it will give you all these things. Definition join, other data frame, on, optional. Okay, what, how you want to join it. Here, see, all these things. When I hover on this one, this is the definition it has given. Join other data frame on optional. This is a optional one, and the condition it is saying optional, and later in the definition it is saying list the column and how it should join. So left dot right, dot join dot right of, and the join condition, and here it should be how to join it. Okay, so each and every join, whatever we are doing, it will be the same syntax only. So let's see the data. See here, finance, marketing, sales, and IT, 10, 20, 30, and 40. But according to the data, do we have 30? That means the sales one? No, right? So it will not be displayed here, because inner join means it will take the matching records only. Matching records in the sense, this department ID, whatever it is here, it should match with this department ID. And for 10, what is the value we have assigned here? Finance. So that will come as a, that will join as a finance. For 10, 20 it is marketing, 40 it is IT. So this is how it usually get joined if it is a inner join. Now I'm explaining you the left join. So in left join also, EMPDF will be the left one. EMPDF dot join of what is the right table? Department DF. Okay, department DF and join this one. What is the condition again here? EMPDF dot what department ID. Department ID is equals to DVT DF dot department ID. Comma. Okay, we have join condition and now it should be the left join. Okay, let me write show to get the data. Yeah, so this double equal to. In the left join, what it has done, it has taken 10, 20, 10, 20, 10, 10, 40. See, Jane, how many records are there here? 1, 2, 3, 4, 5, 6, 7. Correct? So out of 7, we have, do we have 30 here? No, right? But see, but Jane is the one which is also, her department is also not listed here. But we still get it because this is the left table. Left table is employee table. So all the records of employee table plus matching records of right table, we will be getting it. So since Jane is not having any department, we will be getting as null values here. So this is how it will work. Now let me do the same thing here for right join. Let me execute it. This time, see, for sales department, we don't have any employees. So what it has taken from the right table, it has taken all the values, including 30. So all the values in the left table will be null for the 30 value. Okay. So this is how the right join will be working. I know you all are aware of this SQL joins and this is the syntax. There is a little bit of syntax variation we will be discussing in this PySpark. But rest all, whatever we are discussing now, everything you might have heard, you can correlate it with SQL only because we are using the same things here. All the joins, whatever you heard, are equal to the things in SQL. Whenever we read SQL, I mean, whenever we learn the SQL, it is the same thing here also. But only thing what differs is how you uh, how you integrate SQL with PySpark is what it is different. Okay. So rest all it is the same thing. Now let me show you how it will be doing for full join. See, let me show you one more thing. I have taken right. Now I'll be taking as a right outer join also and show you what is the answer for this one. See, the same answer. Right outer join is same as the right join. Whatever you want, you can use. Either you can write right or right underscore outer, or you can write like right outer also. Everything is same. It is the same thing when you work with left also. Left outer and left underscore outer. All will give you the same answers. Okay? Clear everyone? I'll take the silence as yes. So now we have taken the right join. We have seen left join, right join, and now we are going to see full join. Okay. Wait, right join and right join. Full join. I'm creating. So again, I'm taking employee df dot full of what department df. Comma condition will be the same. Employee df dot dpt underscore id is equals to dpt df dot department id. And now on which join we are going to do, it is full. I'm taking as full. Dot show. Everything I'm getting error here only. Okay. Okay, full capital, it should not be written. It should be in small letters, it is saying. The day full outer. What it is there here? Just full outer, right? So here also it should be full outer only, no? Why it is not showing up anything? It should ideally work. Let me see the syntax once again. Df full join equals to employee df dot full of. So join, not full. Okay. So now it will work. Okay. So in full join, what it has done, see, for sales department, we don't have any employee. It has returned that value also. And at the same time, see here, Jane, her particular what department ID is 50. And this is not there in department ID. This is also getting displayed. So whatever the values were not there, there we are getting null values. So this is how it differs. And one more thing, when you are dealing with SQL joins, even the null value will also consider as one of the value. Means, let's suppose, see, I'm saying you the example from interview perspective. Okay. Let me take one particular row. Let's take this department name as a row. Okay, null is there na here, and take one more. This is in one table, and let's take department name in another particular table. There also you have null. When you do any join, na, what it will do for inner join, this null will be joined with this one. It will give output. And again, for any other null value, this will be joined with another null also. Okay, let me not confuse you. We'll discuss this when we are dealing with PySpark SQL. For now, in DataFrames, learn this. I will show you all the examples with respect to PySpark SQL, whatever it is important from interview perspective. Okay. So this is what the full join do. Now we have discussed inner join, left join, right join, and full outer join. See, here we have left semi join and left anti join. Let me show you what output it will give us. Left and T. Let's see first the semi one. Semi one is equals to empdf dot join of dbt df. Condition will be the same one dot dbt id. It will be equal to dbt df dot dbt underscore id. So, comma, on what condition we have taken department ID. See, it need not to be a single condition. It can be of multiple conditions also. You need to separate it with comma only. Okay? And it should be left semi. Let me show you what it will give the output. Double equal. See here, Smith, Jerry, Joe, Sam, and Rose. We don't have Jane here, if you remember or not. Jane, her department ID is 50. Since her department ID is not matching with the department table department ID, we have excluded that one. And we have taken only matching records from only left table. See, from the above table, if you see, here we have also department name and department ID. But when you see this particular thing, you could see the department name and department ID are not getting joined. It is taking only the left table only, not the right table records. And it will be taking the matching records of the left table. That's all. That is all. Please take a note of all this. I'm saying it continuously. So let me give you, you already know inner join and left join. You might have taken a note. So take it from here. Right and right outer are same. Take it fast. Quickly, we can move to the next one. Going to the next one. Full join and left semicolon. Have you ever thought this join? See, what we have learned is transformations. In transformations, narrow and wide transformations are there. You keep on taking a note of this one. I'll be just explaining. Okay, just hear what I'm saying. Okay. So in narrow transformation, the shuffling is not required. But when it comes to wide transformation, shuffling is required. And these joins are particularly into the wide transformations. So think from the perspective like if you are dealing with very, very, very huge data. So when you are dealing with huge data, what it will do when you are applying a joining condition, it will shuffle the data to any extent, which is very, very expensive dealing with joins. Correct? So whenever, whatever the join you write, whatever the join, be it inner join, left, right join, full join, whatever it is, it will definitely be an expensive operation, expensive transformation operation. So we have few things which upon which we can optimize joins. When you are working with PySpark, in PySpark, the joins are very expensive because they require shuffling. Remember this point. Take a note of that also. You can create one notepad with the important points. Okay. And whenever I say this is very important, just keep a note of that particular one in that notepad. Okay. Every day. So by the end of this course, you will be having all the important points in one particular notebook. Okay, it will help you. You can create one inside this one, one notebook inside this Databricks only, or you can create a note in Notepad also. It is of your choice. Okay, but make sure from today onwards, create a notepad having all the important points. Okay. Whenever I ask you question, you can quickly go to your notepad. Every day when you come to the class, before coming to the class, when you read those all important points, it should be good enough to come to the class. No need of uh, keeping an eye on all the notebooks which I have discussed till now. Rather than doing that one, take a note of that. It is very helpful for all of you. See? So today we will be discussing on these joins and optimizing the joins also. So from tomorrow, if in per time permits, I'll explain you. Else tomorrow I'll be taking the optimizing of joins. Okay. But there is one more thing which you need to understand is uh, joins are very expensive because it requires shuffling. So take a note of this one and I will discuss on that one later after discussing the left anti-join also. Okay. I hope this is also completed and I will show you left anti-join. In pdf.join of dptdf comma and the joining condition is employee df dot give me. You can write it on your own. This left anti-join dpt id is equals to double equal to, because every time we are getting this error, na, double equal to dpttf dot dpt underscore id and left it should be left anti join. Let me show you that particular one. See here, the answer is like Jane is not the matching record. Jane department ID is not matching with the department table's department ID. So the one which is not matching has only reflected in anti-joint. And when it comes to semi-join, only the matching records of left table. See, you can think like, okay, now you have left semi-join and left anti-join. Why can't we have right semi-join and right anti-join? See, let me give you that also. Actually, those are not there. If I write right, and you can see what will be the answer for this one. See, what it has said is unsupported joint type. You have only unsupported joint type right anti. Supported joints are inner joint, outer joint, full, full outer. See, all these are same. Outer is same as full is same as full outer, full underscore outer. These all are same, but only this naming is different. Okay, left outer, left underscore outer, same. Right outer, right out, right underscore outer are same. Left semi is same as left underscore semi, and it is same as semi also. Means here if you execute only anti, also it will give you the same answer. Left anti and left underscore anti and anti are same. And we also have cross join and self join in this data frames also. Okay, let me execute this anti and show you what is the result. It is the same thing. So be it left anti or anti, it is the same one. It is taking the data only from the left table. Okay. I hope this is understandable for everyone because data frame joins, we have this new joins left anti and left semi. So definitely you'll be getting a question on this particular one during your interview. I don't say that everyone will get this question, but yeah, many of you may get this question. Okay. So be prepared with what is the difference between left, how many types of joints are there will be the first question. And if you say this anti and semi joints also, they'll ask you what is the difference. So be prepared for all of them. Okay. And apart from this one, we also said that we have also a self join and a cross join. You all know, right? Cross join. What it will do, cross join is the Cartesian product of both the tables. So think from the perspective that you have very huge data. So what it will do when you apply a cross join, it is not a feasible thing, right? So in real time, na, cross join is not used in many of the cases. We will always try to avoid that one, and because it is not feasible one, and it is very expensive. Okay, let me show you now the self join. So self join itself, it is saying that joining the table itself is what the self join is. You already know the thing in SQL. Let me show you how you can do it in this one. So for that one, the use case of the self join will be like, see here you have employee ID, employee name, manager ID, department ID, gender and salary, right? So I want the manager name also. What you will do, manager name also I want, but I have only manager ID, but I don't have manager name. But now I want manager name also. What do we do in this case? We will be joining the same table with itself to get the manager name, because see, this manager IDs are same as the employee IDs. That will be the joining condition. So don't worry, I will be showing it now in a practical way. self join. Okay. Self join. Now I'm taking empdf dot join of again empdf only. empdf only. But there should be some difference when you are writing a joining condition, right? So let me take alias of this as emp1 or e1 should be good enough. Okay. Dot. This is second one also alias e2. Okay. So e1 means the first one, e2 will be the second one. Now that you have created this one. Now the joining condition will be the same. E1 dot what? Manager ID. E1 dot manager ID. Manager ID is double equal to E2 dot employee ID. EMP ID, EMP ID. Okay. See, what we are doing exactly here, try to understand, okay? What I want, what is my requirement? I want manager name also for all the employee, for each and every employee who is our manager, not the ID I want. I also want the manager name. So for this requirement, what I have done, I'm joining the same table with itself where the joining condition is E1 of manager ID is equals to E2 of employee ID. Wherever this manager ID is equal to this employee ID, you will be retrieving that particular records. Okay, come inner, this will be inner only, no? Inner join. So let me show you what will be the this one. E1 is not defined. It is saying we have taken okay as E1, but keep it in double quotes. Okay. Whatever the names you take it in a double quote. Name error. E1 is not defined. empdf dot alias of E1 dot join of this one. This should be fine, but let me do one thing. Here we have taken like this, but here it is not working. I'm not sure. Let me try it in one more way. Like we have column of function, right? Column of E1 dot, what is the one? Manager ID, right? Manager ID double equal to column of E1 dot E2 dot what employee ID, right? EMPID. Let's see. It is working. So the thing is, when you are taking alias, just use column of because it couldn't identify E1 dot manager ID, something like that. But EMPDF dot manager ID, something like that, if you have taken, it will definitely work. But when you are using this alias, try to use the column of function. Okay. See what it has done for all the ones for wait, where wait. See, we have joined the same with the same, but did I have taken the employee name as manager name? No, right? So that is the issue here, why it is showing all these columns. Okay. Before writing show off, let me do one thing. Let me select whatever I want. Okay. Select off. Now I'm taking the column of e1.emp id. emp id and I want this column and the column of even dot emp name, employee name, and wait, it should be in double quotes. Joining itself, we will not be getting the answer. So we need to select what are all the columns are also there here. So column of E1 dot manager for ID. Is this the same one? Manager for ID? Yes, yeah. Manager ID and comma column of E2 dot EMP employee name. I'm saying E2 of employee name as manager name. It would be in double quotes, okay? Dot alias manager name. Okay, this is how you can get the answer. Now let's see what will be the answer for this one. Why I'm getting the duplicate values? See, for each and every one, what we have done is, let me take the distant values. Distant of dot. Okay. See, what happened here exactly means we are joining the two table. We are joining the same table with itself. We are joining the employee DF with itself, and we have also given the condition as where the manager ID is equals to the employee ID, and the type of the join here we have used is inner join. Okay, dot select of. Now now that I have joined the employee table with itself, now I'm selecting the required columns. Now the required columns are employee name, manager ID, and manager name is same as the employee name of E2 table. So I have taken the same thing. And now we are displaying the data. So employee ID for 2, here it is Smith. For King, it is Jerry. Wait, something has been messed up. Employee ID is equal to, let's see the data once again. See, this is the employee ID and this is the manager ID. Wherever the manager ID is equal to employee ID, we are getting it. Okay. So, sorry, give me a moment. Sorry. So the condition which we have given is EMP one dot superior manager ID is equals to this one. Na? Let me exchange the same things and see. The condition is true, but it is having issue with employee name King. It is getting Smith and Jerry, Joe, Rose, everyone as their manager name. The employee for each employee. For each, see, for King, it should come as a Smith. Jerry also Smith. Joe. For Joe, it will be King. For Rose also King. So it should come in such a way, but there is some mess up happened here. Let me do this one. You can write the same thing in your spark.sql and check the answer. It should be the same thing, but let me not waste time today. So what we can, I'll explain you the same thing tomorrow. But see, today what we have discussed is we have discussed about all the joins. We have left join, right join, full outer, left semi, and left anti. It is same as semi and anti joins, which we have. Okay. So we also discussed the window functions with respect to the aggregate, which is the first one, which is James, Harry. This one, for this particular one, we have taken aggregate like average, minimum value, maximum value, and sum of this one. For each partition, it has given like this. So we have partitioned by department. So for each department, what is the sum, average value, minimum value, and maximum value? We got it here. So we have seen the window functions with respect to aggregate and all the joins we have seen today. So tomorrow we will be discussing about the optimizing the joins and also the self join. Okay, so you can try the self join from your end once today, and let me get back to you tomorrow on the same thing. So optimizing joins will be like just think, brainstorm yourselves like how we can optimize it. You might have seen in many of your books like bucketing, partitioning, all this. So the same thing we will be doing it tomorrow. Okay, I will explain you all the optimizations which are required for joins tomorrow, and also the self join also. And later we'll be discussing few of the important things. And okay, sir, we can stop the recording.
Okay, madam.
Yeah. So please revise the things which we have discussed today before coming to tomorrow's class, because tomorrow we will be discussing about the optimization of joins. So